All right. That looks live to me. Let me check. There's a live stream. I'm going to take that. I'm going to go over here. And we are live. Awesome. 1 second for people to come in and for me to remember how computers work. All right. Okay. Awesome. All right, so welcome everyone to another wonderful live stream by me, the director of machine learning at the Wikimedia project. So I think probably the start off thing to say is the reason that I do these live streams is that the Wikimedia Foundation is a highly transparent place. That's sort of like the thing about the foundation. And so one of the ways that we're probably pushing that boundary is to just talk about our work, work on it live. There's no presentation. I'm not like showing you. There's nothing prepared. In fact, I'm just going to work on the document in front of me and, come hang out. You can ask questions in chat. You can just chat and chat, whatever you want. And I thought we'd just kind of work on stuff together. If I was really more prepared for this, I would have gotten some awesome music to play, but alas, I don't. So let's get started. So what I'm working on right now is some comms material, but really just like public facing material about the strategic plan for the team. And so as a team, we've always really had a strategic plan. In fact, I'm just going to call it a strategic plan. Plan comms. So we've always sort of had a strategic plan that we've used every single time we've sort of moved forward, and that's what we make year by year and sort of think about it. And it's often not the most technical document. It's really for other people to understand how we're moving forward and for us to sort of think about it. It is, like everything else in the foundation, a public doc, so I can actually paste it into the chat. You're all welcome to come. I think everyone even can edit it. I actually worked on this document live a few weeks ago, and there was a bunch of people who put in, various kind of interesting comments. The purpose of this is sort of the point that I want to get through this document is to have something that we can end up showing to the community and to put out there and be able to talk about what we're working on and have people have some idea, because I've been relatively quiet about it. Mostly because I think one of the things we failed at, and sometimes we fail at a lot at the foundation, is sort of making a promise that we're going to do something and then not doing something. And so I was super specific to like try to not make any kind of promises about, where things are going to go until we felt like things are settled. And so a year ago, we had our first strategic plan, and this is the one that sort of we're working on now. Here's a question. Other than adversarial work, is there other stuff the ML team at Wikimedia works on? Yeah, there is a lot. Actually, so quite a lot of the work that we end up doing at the foundation on ML focuses on editor experience. That's sort of the place that is really a good sweet spot for us as a technical team. So for those who don't know, the Wikimedia Foundation is the foundation that supports Wikipedia, but we don't edit Wikipedia, right? We try very difficult, like all the content on the site, all that effort is owned by the community, and we're there to support them and make that an awesome experience. And so from our perspective, we don't want to use models that end up doing things like, say, deleting an article and that kind of stuff, right? That's not the best relationship we can have with the community, and it's not our content, it's the community's content. The thing that we can do is make that experience for the community really great, and make that experience particularly for an editor, really a fun and enjoyable experience. And there's various ways that we can do that using ML, and I can talk about them now or in a bit, but definitely two that comes to mind is things like article quality prediction and vandalism prediction are there to help editors know where they're supposed to, where they might be able to like spend some time to add the most value. And that kind of stuff is what we're trying to do, is get to the point where an editor can come in and have some kind of hint of where we might think they're best, where they can spend their time to do some really good work. So say something, oh, here's some bad vandalism. How can we detect that fast? But there's also like other areas that are really interesting. There's a project right now that is actually expanding to multiple communities on Wikipedia called Addalink. Addalink is a project where new editors receive a prompt which says, hey, we kind of think that this particular phrase in an article might be a link to another article. And that kind of recommendation is actually driven by ML, and what we're doing now is trying to expand that to as many languages as we can. The reason that that's a really good experience is that if anybody who has tried to edit Wikipedia and been unsuccessful, it can actually be pretty daunting, right? It's like your first edit, you're first getting introduced to the site, you're first getting introduced to the community, and then like you make some edit and it's immediately like slapped down. A better way from a UX perspective would actually be to provide some means to give an editor a few good edits under their belt at first, so they start to see what an edit looks like. They feel good that they've had a good experience, that they've made the site better with a change. And one way to do that is actually to suggest basic edits that they can do to sort of get them, get a few successes under their belt before they move on to more complicated stuff. And that's sort of the focus of the Addalink project, which is driven by ML, and my team's the one who's sort of training the models and expanding them as it works out. That kind of stuff is probably like the bread and butter that we end up doing. I know like the vandalism stuff and disinformation is sort of like the top part of it. And I think that's really, really important work that we don't want to drop. And also, I also think some of the stuff that makes me most excited is the things that actually make the experience of the site better. And there's lots of ways that we can do that while having the experience be really transparent that we're recommending something to a user. And I think that's probably something that we need to get better at. But I think there's lots of opportunities there. It isn't just all anti-vandalism, although that's like a huge part of it. Although literally at the very first part of this document, you can see the very first thing I do is like try to explain ML. I'm like, well, everyone knows the vandalism example. Let me just use it. So this is like this classic explanation of ML. I'm really just adapting it for this purpose. The idea is that in the, there's a human approach that we have Wikipedia edits, and then we have human volunteers, and the human volunteers are detecting which ones are vandalism or not, right? They're the ones who are actually sitting there detecting vandalism. They're really good at that. Like, we know they're good at that. We have all this information that they're just the best people at detecting vandalism, even nuanced vandalism. They're just really good at. That is awesome. It's also like a pretty rough experience for a volunteer, right? It's not generating new knowledge. You're kind of just like trying to clean up a lot of like bad behavior. You're exposed to a lot of negativity. It requires like a lot of work. It's pretty, not that exciting. And so like scaling that out to like lots and lots and lots of Wikipedias is pretty difficult. I think we'll always, use that approach because Wikipedia is a human-centric approach, but there's other things that we can do. The other one that we also do is a rule-based approach. So this would be, there's a set of Wikipedia edits, and there's a set of rules, like, for example, a list of bad words. And if an edit includes a bad word, you mark it as vandalism. That already happens. There's quite a few community bots out there that end up doing this approach because, you just don't want certain kinds of words being in there. And if there is a kind of word, it's pretty obvious that that's probably not something that you want to like let go without at least being flagged and having a more senior editor take a look at it. There's a third option, which is the one that my team works on, which is the ML-based approach, right? So in this, we take those typically human-generated labels for bad or not, or we take like a history of like whether or not a particular edit was reverted by a human editor or not. And then we use that to figure out, to try to approximate what we think a human editor would do, and then we apply those to Wikipedia edits, right? So we take those vandalism labels, we take Wikipedia edits, and we use ML to like find the rules that we want to apply to all edits. That is sort of a combination of the two first ones, the human-centric approach and the rule-based approach. I think, I think it approximates both. I don't think we're ever going to just use one, because frankly, rule-based approaches, right, using a bad word list is really scalable. That is easily scalable. It's time tested. It really works well. The human approach is obviously the gold standard because humans are frankly really, really, really good at detecting kinds of vandalism. But we can at least approximate that with ML. And that is what a lot of our models end up doing, is trying to detect bad faith edits and that kind of stuff. And some of the newer stuff that we're working on is sort of trying to expand upon that. This next section, which no one had any comments on it when I'm writing about, so I'm going to assume is like the most amazing writing ever written. I suspect it isn't. It's just talking about like how we end up thinking about a model. This is actually something that came up pretty interestingly early on with model cards. So one of the things that we've been trying to work on, which I actually have a really cool example of, let me go show it right now. One of the things that we're working on as part of the process is model cards. Model cards were created or invented in a Mitchell et al. Paper in 2018. The idea behind a model card is to have a public document that describes what a model does and how it should be used and how it shouldn't be used. And actually, quite a few of the office hours I did prior to this one was me trying to figure out model cards and try to understand like where we could use them, where we can't. And after quite a few iterations, we came up with this approach. This is a, you can ignore this title, which is just where we put it. But the idea is like this would be a English wiki predicting whether an edit was made in good faith or not. This is the model card for it. The idea is that we would create a model card for every single. I can also put this into chat for folks. The idea is that we would have a model card for every single model that we end up hosting at the foundation. And so it's very clear to the community where ML is being used. And one of the most interesting parts is that because every single wiki page naturally comes with a discussion, a talk page, which is up here. Let's see if I can highlight it, which is up there. That means I can click on this, and actually we have like a natural place to go for people to talk about the model, to say that the model is wrong, to offer improvements, to ask questions, to expand on it. Like there's just lots of interesting places to go if you include that talk page, and that's what we're really going for. So historically, we haven't had any model cards or any kind of like really strong index of what models we had in production. And we have hundreds of models in production, or at least, I mean, between 100 and 200, I guess. And because of that, making a model card for every single model is our best way of participating with the community and saying, hey, there's no hidden stuff here. There's no secret thing. Like, this is exactly where it goes. We're being very transparent about what everything that's happening with around ML. And so this was our first attempt at it. We took just one particular model, which was that English Wikipedia one, but we're hoping to expand it more in the future as we, grind through it. It actually takes quite a while to make it because you have to like dig through a lot of different stats and stuff. And I think, probably one of the most interesting differences with model cards is that it's not supposed to replace documentation, which is an interesting concept for me to wrap my head around. It's not supposed to, like, we have our own documentation for all these kind of models that's publicly available but isn't on a different wiki. This is about trying to have something that's more public facing, that is about the community's discussion around it, about the public's discussion around it. And it's our acknowledgement that this model that this model is being hosted by us and that we're responsible for it. And so, we have hundreds of those to make, but one of the things that we were talking about, like with what is a model, is like, okay, you have one model card, like say you have a model, right? And then you make a model card for it. And then you end up, say, making iteration of the model. How do you reflect that that change was made in the model card? Because one thing we would want to do is that you should be able to download the training data and download the code that was used to generate that model. And so like you can go run it yourself, right? That's sort of what we're going for. But if we're making lots of iterations for it, or say we're training that model nightly, which is where we'd like to get to, well, now you need to create snapshots of the data and snapshots of the code at a given time, and then also put them into the model card in a way that was like visually like easy to understand, so there's like lots of different versions of it? Or do you just do the latest version of it? You know, it's I don't really know exactly how we're going to do that right now. Like the obvious way is to do the most recent version. Like a model is like containing all the different versions of it, like conceptually. But I would like there to be a moment where a researcher could go and like figure out the model from 2 years ago, and then download the data, download the model, and then see what happens. Because if we're training models all the time, it's kind of a moving target for researchers, which is not the greatest situation. There's a question in the comments. How are the 100 to 200 production models being monitored? Additionally, how often are they updated? They are monitored through, let me go find it. We use Grafana. Let me go see if I can find where the actual part of it is. This is the nice thing of working at the foundation. It's all just live. So the old infrastructure that we're currently migrating away from, this is the actual analytics for it. It's all public. Let me go post it into chat. So this is the actual analytics that we use for when we're trying to figure stuff out with the process. There's obviously like more detailed logs and stuff like that we can dig into, but this is sort of the top view. If you go over to this side area over here, ORS is the name of the production like model hosting system. There are 18 servers in 2 data centers, and they're listed 1000 to 1 to 1000 to 9 is one data center, and 2000 to 1 and 2000 to 9 is the second data center. And so this shows all the different traffic on all the different servers. What I do wish, and this is something that we've like thought about for a while, is that like this is clearly insufficient for what we care about, because to your second point, how often are they updated? Because they're trained manually and because they're deployed manually, it would be years in between model updates would happen for some of these models. And during that time, there's clearly a significant amount of model drift that would take place in that period. And we know that that model drift exists because it should exist, but we also know because some of the researchers that we talked to have said, hey, I would like, when I was making a paper, I would run the model and it would like, give this performance. And then 5 years later, I would go write another paper and run the model, and then it would give like a worse score. So like clearly the score is getting worse over time, which is the definition of model drift. We need to get better at this. And one of the reasons that we're moving to a new infrastructure, particularly what we're calling Liftwing, which is a Kubeflow based infrastructure, is the ability to provide stronger performance analytics on individual models, and to be able to run a lot more experiments. So for example, we can do shadow deployments, which is where you deploy 2 versions of a model, and you provide any kind of request that comes in. The production version of the model sends back the prediction, but you actually generate predictions from both models, like both the production model and its shadow version, and you save them. And so you can like see how the shadow model would have performed with real world cases. You can also do things like split traffic between 2 models randomly. So you can have, like 90% on one model and 10% on another one, and sort of run those kind of experiments for us to be able to see how things ended up changing over time. The lack of retraining is difficult. Like it's not where we want to be. And for us, I think one of the learning experiences of building out sort of like the new system that we're using is the problems of horizontal scale. So obviously, like we get a good number of predictions at any given time, but there's also a wide spectrum of models. It's not like we have like 4 models and we're really trying to like maximize the optimize like the sheer number of predictions they can generate. There's actually like a large number of models and models of different types. And that means that you run into a situation where you can have the performance on like some kind of model that is, say, Vietnamese Wikipedia or something like that can be drifting more than the other ones. And you sort of need to make sure you're tracking all of them, and you need to be able to like provide new training data for all of them and that kind of stuff. And with a team of 5 people, which is what we are, it's a really, really tough game. And one of the things that we're starting to explore with the research team is language agnostic models. And so the reason why we have so many models is the design pattern that we've used in the past has been based on languages. So there's 330 Wikipedia communities, roughly. Each one is based on language. So there's like English, right? English Wikipedia, and then there's Dutch, and then there's Swahili, and like that kind of stuff, like all the way down to 330. One of the ways that you think about it, and sort of the first pass is like, oh, we should train a model and then go, for one language, and then go to the next language and train a model, and go to the next language and train a model, and that kind of stuff. And historically, the team got through, maybe about 50 or 60 of those languages, and it just started to get wild because it's a lot of different communities, a lot of different languages to deal with, a lot of different models that maybe the team doesn't speak, and you start to make some kind of like really difficult decisions about how you want to handle that. The value of some of the things that we're working at with language agnostic models is that we could have one or maybe a handful of models could actually cover all communities on Wikipedia, which means that we can really focus, like we could reduce the amount of models that we're having to host and having to maintain, and can focus more on like just having a few models that we know really well, that the team knows really well, that the community knows really well, and to focus the kind of work on that area. We have replaced one type of model with a language agnostic version, which was a topic model, which is currently running on our new infrastructure. Now we're kind of working on things like predicting edit quality, which has traditionally been a language specific model, and moving that towards a language agnostic model. Although that work is pretty early on in the process because it's just a difficult situation. But yeah, that horizontal scale was not something I expected to deal with, but it's just really interesting because you're just dealing with so many languages and so many communities, and the communities of Wikipedia are in fact pretty unique in how they operate. So to give an example, for add a link, which is where we're using ML to recommend simple edits, link adding edits to new editors, Arabic Wikipedia was like, awesome, this is an awesome, totally cool tool, we love it. And German Wikipedia was like, we don't like it, don't put it on our site. And the reason why is because German Wikipedia, well, I'll go back. On Arabic Wikipedia, if you say have a article on hot dogs, they want, and like in the article there's like aluminum, like you use aluminum foil to wrap the hot dog or something like that. Like that's the sentence on one of them. They're totally okay with you linking aluminum to an article about aluminum foil, or aluminium if you're in the UK, right? In German Wikipedia, you would only link to other articles if it is specific to making the specifically helps you understand the core notion of what a hot dog would be. And so like linking to aluminum from aluminum foil, which you wrap around the hot dog, doesn't really like meet that bar. So they would not want you to add a link to that. And so like that's the fact where like different communities have different goals for what they're going for and different norms of behavior, which again means if you're making a language per, you're making a model per language, you start to like really dig into these like, really difficult tasks. Whereas a language agnostic model, you can sort of pare it back a little bit less on the quality front because it isn't like super specific to that language, but it means you can scale out a lot better. And it means that a lot more languages have the coverage of that model actually being able to work for them that they wouldn't otherwise have, because there's 330 models. We have like probably 60, like our most spread out model, which is that it detects whether or not an edit is made in good faith is probably like 60 languages. And so in that case, like we're not even covering close to 330, right? And so like it's going to be a hard task to expand every single model to 330 languages if we're not sort of removing language as the limiting factor with things. So that was hopefully that was a good answer. But what is a model? Has spent way too much of my time thinking about. This is me sort of explaining away. MLOps. So this was the thing that this is actually from Wikipedia. I should add a little here. Let me add a comment here. Add link to Wikicommons, which is where I got it. MLOps is like where actually the team spends a lot of our time, because we do have awesome researchers who work at the foundation. And while we are responsible for some of our own models, a lot of the stuff is working with researchers and ideally other members of various teams at the foundation to host models that they want to do. So for example, the team who runs search, they have some models that they run. I'd love it if some of the folks on, in other parts of the organization who wanted to run models could make a model and we'd help them make it. And we would like make sure that like we could deploy it and that kind of stuff. But MLOps is where you go. Like the problem with that horizontal scaling is that you can't make sort of, well, let's step back. Like one of the issues that you run into that you don't have when you have like one model. When you have like one model, right, you just like load it into a Flask app and put it out there and you're like pretty good. But when you start to have hundreds of models, you start to run into the situation of like, well, how do you monitor all those models, which was the question. How do you end up knowing, like, how do you turn off a model, right? So like a regular says, hey, you can't do it, or German Wikipedia says, hey, we don't want it. Like, how do you quickly be responsive to them and turn off that model? How do you quickly make changes to the model? All that kind of stuff. That's sort of that like operations side of things, which is not at all about model creation. It's just about having lots of models running at all times. And so that's what the team has like been spent a lot of time focusing on, which is kind of interesting because when I joined, I was like, oh, I'm going to make a lot of machine learning models. And it turns out that I actually spent a lot of time figuring out how to put so many models into production and maintain them and watch them and monitor them and that kind of stuff. Another question, how much feature drift is acceptable given the feedback process, or do you prioritize which models get updated today? Right now, we accept way too much drift. That's really the big problem, because the issue is that we don't have an accurate number about drift of every single model that we have in production. And the worst case scenario for us is that the model is actually harmful. And we don't like, because we don't, if you have enough drift, the model will start to become harmful because it'll start to just like not be accurate at all. Like it won't be a useful tool. It'll start to like flag things that shouldn't be flagged and make the user experience worse for everyone. And how much is acceptable? Way too much. Like we accept way too much of that feature drift, which is one of the reasons that we're trying to move to that language agnostic model approach, because we can actually then deprecate a lot of the existing models and then focus that time and energy on those few models that we know cover all Wikipedias, and we're very able to monitor them. I think with the feedback process, we definitely do get feedback from the community. In fact, let me go. I can actually show you one of the things that we're working on now. I'm sure everyone knows Jira. We use what's called Fabricator, which is basically a Jira. And one of our engineers, Kevin, is looking at this ticket. This is the actual work ticket, which we groom every single week. One of the problems that came up is that if you include the SVN family template, which you don't need to know about, but basically if you change the family ticket in Farsi Wiki, it actually changes the score of the article quality, right? It says that the article is like worse because you're using the ticket. And so if we go back to the ticket, there's been a lengthy discussion about on my team about like, well, how much does the change matters, and this is sort of the explanation of what it didn't work. And then we did another test which showed that it actually clearly changing the tags was screwing things up a bit. And so now we're trying to work on a fix, but this is because a community member jumped in and made us made a comment. My guess is that the community doesn't tell us when models break a lot more than we would hope. I think a lot of times they just kind of accept that it's acting wonky, or maybe the drift is slow and they don't realize it. And so we need to be monitoring it on our end much better. I don't think we can just rely on the community again, because it's not a good sort of community task, because it's kind of like it's amazing this person realized this. It's actually like really impressive that they found this thing, found this bug. But we should have caught this. Like, we just should have caught this way earlier, and we should have been more on top of it. And the fact that we didn't is a bummer, and it's a lesson for us that we should have seen. Oh, okay, suddenly there was a big drop in performance. Okay, we need to go find it. Hopefully that answered it. Where's my original doc? Machine Learning Foundation. So yeah, I think probably, the interesting thing about this section, which I talk about, is that ML has been used at the foundation or used on Wikipedia for a long time. And from the foundation's perspective, like, we've been using it for about 5 years, which is pretty new compared to the community, which has been using it for really, really, really long time and in pretty interesting ways. And so, one of the big ones is this ClueBot-NG. ClueBot-NG is the big anti-vandalism community bot, which doesn't use our system at all. They actually have their own human labeling approach, their own model training process, and that kind of stuff. And because it's a community-driven app, the app has a lot more freedom to make changes, because it's the community, like the community's app that they can do whatever they want with. And so it's a lot more aggressive than our applications, which is awesome. But there's just a lot of ML that happens on like various community bots and that kind of stuff. For us, like we stay like well back from that, right? The communities have control over their content. The communities are the ones that are allowed to do, what they want to do with their community. And we're there to support that. We're not there to jump on their toes. Another question. I know Wikimedia hand rolls a lot of tech, true, and doesn't buy. You have to buy to build your own tech, sadly. But have you all looked at products to monitor model drift? Yeah, no. So it's definitely, one of the issues. So when it comes to buying, so for those who don't know, the foundation almost exclusively uses open source tech. So that was the reason that we make almost all of our decisions, because we as an organization believe in open source. Obviously, Wikipedia is open source. That openness is sort of the grand philosophy around everything. And it means that we should be using our developers' time to work on open source tech where we can provide, we can actually give back to those organizations, right? If we fix a bug, we should submit it back and that kind of stuff. That is the sort of key functional thing, which is why we don't use AWS for like production stuff, although it has been used some places. So there's always like the exception to the rule, but we're not, we don't do a Google Cloud, although like sometimes it's, very used. We tend to not use SaaS products, although occasionally we do. I'm throwing the caveat in there because it's always the exception, but for the most part, we don't. And so, one of the things that I worry about with having like a SaaS product to monitor model drift is that if this was a company and I was hired at the company, I would say, great, let's just like put down the credit card and we'll use that model drift calculator and that kind of stuff, and we'll just kind of run with it. I think one of the issues that I keep running into with a lot of these SaaS products is they're not designed to be publicly accessible, because that's not their goal, right? Their goal as a SaaS product is to be bought by a company, and they provide you with a login, and you need the login to seal your stats and like that kind of stuff. And so you can imagine something that monitors model drift, but like you actually have to like, have a private account to see and that kind of stuff. We don't want that. We don't want that like a lot. We don't want there to be like model drift is given by a secret algorithm of which we can't tell the community, or the community can't go in and see it directly. Like, this is the big thing about Grafana. Like, this is our metrics. This isn't private. This isn't secret. You can log on to this web page. You don't need to log on. You can see everything that I'm seeing right now. That's sort of, the fun part about the foundation. But it does mean that like, if we ended up doing something like paying a company to, detect model drift, you wouldn't be able to see it yourself, right? I could see it because I have the credit card, but you all couldn't see it. And it's important that you all see it. Like, you should not trust the foundation. We should do stuff to make it obvious that you can just see everything that we see. It sounds both annoying and fun is one comment, and that is entirely true. There are moments when it's really, really, really fun and interesting. So for example, I'm live streaming this and you're seeing what I see. Like, the last time this system was down, this was the first page I went to see what in the world was happening. You can see, tons of stuff that I see. Like, I'm live streaming my work. I could live code my work. Like, I could just live stream me coding. All that stuff is totally okay. The downside is that there's a lot of tooling that doesn't really fit that because it's too private. It's too locked down. It's not open source, which is like a big part of it because, we are paid by you. Like, the donation that you give, this isn't really a pitch for donations because I'm not on the fundraising program, but like, my salary is paid by you. Every server is paid by you. Every hour of time we spend on something is paid by you. All the electricity costs are all paid by you. Like, that is how this whole foundation works. And it means that you should see what we see, right? There's no reason why we should hide there should be some secret model that you can't see unless it was dealing with like private information like PII or something. Like, there's no reason that you should not just see everything. And so along those lines, it needs to make sure that as much of the tooling as possible does that. It then makes things a lot harder because, again, I can't just put my credit card down on AWS and be like, SageMaker, fix my problem or something like that. You have to find other ways. And it's, it's fun. So like, one of the things that I probably will investigate on a live stream is NVIDIA announced. So we've stayed away from NVIDIA GPUs because NVIDIA CUDA, so the sort of the drivers for the NVIDIA GPUs are not open source. Whereas AMD GPUs, there are open source drivers for it. So we use AMD GPUs because that's we're trying to stay open source. It does add like quite a lot of complexity to things because NVIDIA is sort of the de facto standard for GPUs. When you're dealing with hardware, a lot of tools, including things like Kubeflow, assume that you're using NVIDIA GPUs. And so if you're not using NVIDIA GPUs, you're sort of off on your own a little bit to kind of figure things out. And we've done a pretty good job with it, but it does make things a little bit more complicated. But NVIDIA announced that they've open sourced, I don't understand if it's the whole driver or part of the driver or something about their GPUs, which if so would make things pretty interesting because we could then make a pretty big purchase of GPUs because right now we have just a very few. And so we're trying to sort of stay in open source. So if there's ways of getting NVIDIA GPUs to be open source, that's great. If not, that's fine. We can use AMD GPUs and keep doing what we're doing. But it's just one of those things of trying to stay in there does make things annoying sometimes, but mostly fun. You get the right attitude. I think it's hard to really be that annoyed with it when like the goal is just to be public. To me, I didn't appreciate before how much the foundation is public, like how much that is just like open and you can see. So like, this is an example that I've given a few times. Let me find it right now. So this right here, which is this right here is our. I'm not logged in apparently. Let me go see. I will get it up. But basically, like, we use IRC for our team's internal chat. And you might think to yourself, which is what I thought to myself, like, wow, that's wild. Why would you ever possibly, here I can go, why would you use IRC? Why wouldn't you sort of like just use Slack and that kind of stuff? And the foundation does have Slack. So it is being used in some areas, but I'll say myself as guest 71 here. But the reason that people use IRC is because it's public. Like, that's the reason that we use this, is because you can come into this channel. This is my team's internal channel. You can't see the history. You have to go to like one of the history pages to see it. But like, this is the actual like chat room that we do everything on. And if you go here, typically at like pretty early on Pacific time, but sort of daytime European or African time, my team is in here discussing stuff and like talking about the latest thing that they're pushing or debating how to do something or something like that. So you can sort of see a lot of stuff. But again, there's annoying parts of it. So for example, like RC doesn't save history, so you can't see any of the conversations behind this. You actually have to go somewhere else to see the history of the chat. So like this is what you pluses and minuses with everything. So this is where going back to the original document. Are we out of time? Yeah, we are out of time. All right. I'll save this one for next time. I mean, I did just want to ask people: do people find this like useful for stuff? I never know if anybody cares of what we do all day. We act as if people care. I think that's definitely important. And I'd like to do more of these streams and maybe focus on things like coding up some models and people can see stuff. Because we're not beholden to an investor or a corporate entity or something like that. Like you're all the reasons that we get paid. So it's cool to put something out there that people can see and interact with. But I don't want to do it if everyone hates it. Okay, super cool. Okay, cool. I went 40 minutes instead of 30 minutes, but we'll do more in the future. Awesome. Thanks everyone. I'm glad people come. I'll try to advertise a little bit more next time and get back into this, but we'll see. All right.